In this video, I'd like to talk about factoring quadratics by grouping. So we have this quadratic equation here, and notice that the coefficient on the x squared term, so your highest power term of x, this coefficient is no longer 1. So if you've watched previous factoring videos, we started with simpler expressions, like let's say x squared minus 4x plus 3, and learned how to factor these. You can factor this into x minus 3 times x minus 1. And if you check it, you can multiply this out, and it will remultiply to this quadratic expression. So these are much simpler. There are a couple different ways to approach these, and honestly, you can use grouping for this method as well once you learn it. But in my previous videos, I used a reverse FOIL method to kind of guess and check our way to the answer. But when the coefficient on x squared, this number here, when this is not 1, then these problems become much more difficult. So we have to be more careful with how we approach it. And this method of factoring by grouping, we essentially want to take this middle term here and break it up into 2 terms. And with a grouping method, like if you had 4 terms, you look for common factors with the first 2 terms and maybe the second 2 terms, or you could rearrange this. But you'll look for a common factor here, you'll be able to pull it out. You'll be able to pull it out here as well, some different common factor maybe. And then what's left on the inside should be the same in both of these, and you can factor that out from both. So if that was confusing, I think it'll make more sense when we actually go through an example. So like I said, the general idea is we have to break up this middle term into 2 different terms. But we have to know how to break it up. And for this part, I'm just going to go through and explain how to do it, and we can talk about why we do it this way later. So we're looking for 2 numbers whose product is going to be equal to the coefficient on the first term times by the constant term. So in this case, it'd be positive 15 and minus 4. And then these same 2 numbers, remember we're just trying to break up this middle term, but these same 2 numbers would also add up to the coefficient on the x term, the middle term. So in this case, minus 4. So the 2 numbers we know are going to multiply to minus 60, and they're going to add to negative 4. So to start this, the most straightforward way to do this is to look at all the possible factors of negative 60. So if we write those down, we could have 1 and minus 60, or minus 1 and 60. We could have 2 and minus 30, or minus 2 and 30, and so on. With 60, there's actually quite a few different factors. We could do 3 and 20, with one of these being negative. We could do 4 and 15 with one of these being negative. And we can do 6 and 10. We can do 5 and 12. So 60 has lots of different options where you have these pairs that multiply to give you 60. And of course, we're looking for negative 60. So in all of these cases, one of these is going to have to be negative and the other can be positive. So our next step, once we write all these factors, is to figure out which of these pairs, these factor pairs, would actually add up to negative 4. And in this case, it would be minus 6 and 10, because minus 6 plus 10, well, this would actually give you positive 4. But we're looking for negative 4. So if we switched the negative signs here with minus 10 and positive 6, then this is really the one that works for us, because minus 10 plus 6 does give us minus 4, which is what we're looking for. So we found the 2 numbers that we needed to break up this minus 4x term. So I'm going to rewrite this quadratic expression by actually breaking it up. So let me change colors. So we have 15x squared, and instead of being minus 4x, we're going to break it up into minus 10x plus 6x, and then we have minus 4 at the end. And this should make sense that you can do this, because minus 10x plus 6x does simplify back to minus 4. So it's a valid operation up to this step. And now, once we have our 4 terms, we're going to factor by grouping. So we're going to group the two first terms together and the two second terms together. And we're going to ask ourselves, what is the greatest common factor in each of these pairs? And for the first one here, notice that 5 would divide evenly into both terms, and the variable x would divide evenly into both terms. So we're going to factor out 5x, and here we're left with 3x, and here we're left with minus 2. And now we'll do the same thing for this second pair of terms. And the biggest number that divides into both of these is just 2. We can't pull out an x since the constant term doesn't have x in it. But we can pull out that 2. And so here we'd be left with 3x, and here we're left with minus 2. But notice that we ended up with the same expression in both of these sets of parentheses. And because of that, you could think of this all as one term, and this all as one term. And each of these terms share this common factor. And so we can actually factor that out from both of them. So we can pull out this 3x minus 2 from each of these terms here. And when we do that, so I'm pulling that out, I'm factoring it out. And so here I'm just left with a 5x. And here I'm just left with positive 2. And so this is the factored form of that quadratic. But you don't want to just assume that you did your work correctly. You also want to check it. So we can use the FOIL method to remultiply this out, or you could also just think about it as distribution, because the 3x gets distributed to both and the minus 2 gets distributed to both. So 3x and 5x would make 15x squared. 3x and positive 2 would be plus 6x. Minus 2 and 5x would be minus 10x. And minus 2 and 2 would be minus 4. And you can see this would simplify back to minus 4x. So you get 15x squared minus 4x minus 4, which you can see is exactly what we started with. And I should mention that when we broke up that middle term, that 4x, I wrote it as minus 10x plus 6x. Had you done it the other way, plus 6x minus 10x, and you followed the same process of factoring out the greatest common factor, then you would still end up with the same answer. So you don't have to be careful about which order you put those or which way you group them. You'll still be able to get this answer right here. So with these problems, it's probably a good idea just to practice several of them because the method is a little bit complicated. So let's keep going with these and just practice a little bit more.